All right, now let us go through these questions together. If you look at these questions, obviously this is a two loops questions. Okay, soalan dua loop. Now, as usual, before I solve the questions, I like to label my diagram. So how am I going to label it? I'm going to label this one as R1. And then this is my R2, my R3, R4. Okay, and then battery, EMF1, EMF2. So how are we going to solve these questions? Well, two batteries and four resistors are connected in a circuit where current I1, I2, and I3 their flow as shown in figure 1. So now you're given three different I, and the question is being very nice to use. You're given the directions already. So it means that you don't have to determine the directions by yourself. You don't have to sketch the directions by yourself. So the questions asks you to calculate I1, I2, and I3. So when you have a two loops questions, remember the things that I told you previously. You need one equation from first law. Okay, first law give you one equations, and then second law, it will give you two equations. All right. So now let us begin from start from a first law. Before I start from first law, I'm going to I'm going to give the names to a junction first. So I'm going to call this junctions A. I'm going to call this junction B. Okay, it is quite important to identify the positions of the junction first so that you know how to solve the questions. Okay, so that you can solve it easily. And also because you need junctions to apply first law. So when it comes to Kichoff law questions, if you remember the things that I told you previously, the first step it should be, okay, in our solutions, the first step it should be the principle, the law, okay, the Kichoff first law. You need to set down the law. So summations I in is equals to summations I out. Okay, you need to state this equation because this equation itself, it gives you 1 mark in your exam. Okay, it shows that you understand the principle. You understand that the charge must be conserved in a circuit. So summations I in equals to summations I out. Now let's say I'm going to take junctions A as my reference junction. So what happens at junctions A? You look at the current. The current that is flowing into junctions A, that is pointing towards junction A, is my I2. So I2 is my I in. Okay, I2. So equals to, okay, I1 and I3, obviously they are I out because they are leaving junctions A. So it is equals to I1 plus I3. And because questions A asked me to calculate I1, I2, I3, I know that I have to use the calculator to solve the simultaneous equation. Therefore, I can rearrange the equation first. Okay, I can straight away rearrange the equations rather than I wait until I form all of the equations, then I do the rearrangement again. Okay, so saya tak nak tunggu dah. Saya terus buat rearrangement dulu, tapi saya tunggu sampai saya siap, tulis semua equations, and then baru ulang sekali lagi untuk rearrange. So to make it easier, I'm going to rearrange it first. So I1 minus I2 plus I3 equals to 0. This would be my first equation. So remember, you need to put all unknown on the left-hand side. Okay, all unknown. The unknown in our case is I1, I2, and I3. So these are our unknown. Okay, these are our unknown. All right, next step. Okay, after I'm done with first law, I'm going to apply second law. So in order to apply second law, what I should do, I need to draw a loop. Okay, I need to draw a loop in a diagram. Okay, two loops, because now I have a two loops question. So, okay, this would be my loop 1, this would be my loop 2. Then you're going to determine, you're going to decide, okay, loop 1, you want it to move in a clockwise direction or anti-clockwise direction. If you look at I2 and I3, obviously it will be easier if, okay, if we make the loop to flow in the clockwise direction. Okay, so now I let the loops flow in the clockwise direction. I let the path, okay, move in a clockwise direction to make it easier for me to solve it later on. Whereas when it comes to loop 2, if you look at I2 and I1, obviously it will be easier if I choose the path, okay, if I choose the loop in the anti-clockwise direction. Okay, so now I'm done determining the directions that I want to use, the loop, the path that I want to flow. Okay, now what am I going to do? I'm going to write down the Kichoff Second Law. Okay, once again, this is very important because it gives you 1 mark in your exam. Okay, it shows that you understand the principle. You understand that energy must be conserved in a circuit. So summations delta V is equals to 0. All right, summations delta V is equals to 0. So what are we going to do next? We're going to form equation according to the loop. So let's begin from loop 1. Okay, loop 1, I have it right here. So if I look at my diagram, okay, if I look at the diagram, let us start from junctions A. Okay, you need to choose a point to start. Alright, kamu perlu pilih satu titik untuk mulakan kamu punya perjalanan. Okay, your travel journey. So let us begin from A. So now I'm start traveling from A. Okay, and you must travel according to the directions of this loop. Yang kamu draw punya loop. Okay, loop orange ini. You must follow the direction of this loop. Not follow the directions of current, yeah? Okay, you're not traveling according to the directions of current, but you're traveling in the directions of the loop. You follow the loop. So now let me begin from A. So I begin from A, now I keep traveling. I want to travel from A to B. Why? Because from junctions A to junctions B, they are all using the same path and they are all using the same current. Start from A, ends at B, they are all using I3. Okay, they are all using I3. So from junctions to junctions, you have same current along the path. So now I'm traveling, and now yes, I'm comes to R1. Okay, I have reached R1. So what happens right here? If you look at R1, now I'm travel from left-hand side to right-hand side. That is the directions of my loop. Okay, the loop is going to the right. And at the same time, the current flowing through R1 is also going to the right. Meaning that now it experiences a potential drop as it passes through R1. Okay, so potential drop, we have negative IR. Negative I, which I3. The current that is flowing through R1. So I3, R1, right? So after it passes through R1, now it keeps traveling. Okay, it keeps traveling. And now what happened? It goes to point B. Okay, it goes to, okay, travel. And then now it reaches junction B. There's no more other components along this path, okay, the orange color path. But what happens right now, don't stop at junctions B. Why? Because you want to travel one loop. Okay, so what we do now about junctions A to junctions B, this orange color path, is that these three paths, these three straight line, they are all using the same current, I3. But after it passes through junctions B and enters this loop, this line is no longer I3. We have I2 along this horizontal line right now. Okay, after it passes through junction B. So now, as I keep traveling, okay, and now I've come to R2. So R2, okay, what happens right here is, now the loop is going to the left-hand side. The directions of my journey, okay, I'm traveling towards the left-hand side. And current is also pointing to the left. So current to the left, the directions of the loop is also to the left, meaning that now it experiences the potential drop once again. Okay, experience potential drop once again. And since both of them, they're pointing towards same direction, I have a negative value. Okay, because it drops. So negative, but now it's no longer I3. Now it should be I2. Because I2 is the current flowing through R2 along this horizontal line. So I2, R2. Okay. So let us continue. Okay, let us continue the journey. So it keeps traveling, and now it has come to the EMF1, my first battery, my first EMF. What happens across this EMF? When I travel through, when the current passes through this battery, it's moving from negative to positive terminal of the battery. It's experiencing a potential rise as it passes through here. How do I know that it's potential rise? From negative to positive, from a lower potential to a higher potential terminal. Okay, therefore I know that now my current is experiencing a potential rise as it passes through the battery. So meaning that now I will have a positive EMF1 in my equations. Okay, so I'm now going to keep traveling, and what happens here is now it comes to an end. Again, how do I know that it's a final destination? Because now it's come back to its original position. Okay, so now I'm done traveling one complete cycle, one loop. Therefore, I can then let the equations be equals to 0. So I have negative I3 R1 minus I2 R2 plus EMF1 equals to 0 as my first equations. Okay, as my first equations in a second law. So the next thing, I'm going to plug in the value. Okay, R1 is 4 ohms, so negative 4I3 minus R2 is 2, so minus 2I2 plus 6 equals to 0. I'm going to rearrange the equation. Okay, so I have negative, okay, no, not negative anymore, it should be positive. 2I2 plus 4I3 equals to 6. That would be my equations number 2. All right. So you rearrange the equations so that all unknown, they are being kept on the left-hand side, and the known value 6 is on the right-hand side of the equation. Okay, next, I'm going to look at loop 2. Okay, loop 2. I'm going to form equations for loop 2. So how am I going to form equation? Again, I'm going to repeat the same step. All right, I'm going to repeat the same step. So wait, yeah, let me zoom it a bit. Oops. Yeah, that means okay. Okay, start. I need to restart it. Wait. Okay, so now let's look at loop 2. How are we going to solve loop 2? How are we going to form equations for loop 2? So, well, since we have the loop already, okay, we have determined the directions of the loop, which is anti-clockwise. So let's say I'm going to begin at point A again. Okay, I'm going to start from point A. So now I'm traveling from point A in the anti-clockwise direction. Why anti-clockwise? Not because of current, but it's because of this orange color loop. Okay, I'm going to change it into a blue color. So because of this blue color loop is flowing in the anti-clockwise direction. Therefore, the journey that I'm taking right now, I'm moving right now, it should follow this loop 2 direction. Okay, so anti-clockwise direction. So now as I travel from junctions A and passes through R3, what happened here is the directions of R1, well, from junctions A to junctions B, once again, these 3 paths, they're all going to use the same I, which is I1. Okay, so as I passes through as I passes through R3, the directions of current and the directions of my traveling journey, which is the directions of the loop, both of them, they are pointing towards same direction. So it experienced a potential drop. If it experiences a potential drop, both arrows are pointing towards same direction. Therefore, we have negative I1 R3. Okay, negative I1 R3. As I keep moving, what happens when I pass through this 12-volt battery is that now I'm traveling from positive terminal towards negative terminal. I'm traveling from somewhere with higher potential towards a lower potential, meaning that they experience a potential drop. If it experiences a potential drop, then it will become a negative EMF. So I have negative EMF 2 in this case. Okay, and then I keep traveling, and now I've come to a R4. R4 once again, loop is going to the left, to the right, sorry. Okay, loop is going to the right-hand side, and current is also going to the right-hand side. Both current and the loop the traveling directions, they are pointing toward the same direction. Therefore, I have a potential drop again. Okay, I have a negative value again. So negative I1 R4 because of the potential drop. Okay, because I'm moving towards the directions with potential drop. So as I keep traveling, once again, I reaches a point B, junction B. But that is not the end of my journey yet because I need to complete one loop. Okay, so now I keep traveling towards the left-hand side. As I passes through R2, okay, as I passes through R2, what happened? Directions of I2 and the directions of the loop, they are both pointing to the left-hand side, to the same direction, which indicates that now it's experiencing a potential drop once again. So minus I, but it's no longer I1. Why? Because current flowing along this horizontal line is your I2. So minus I2 R2. Okay, minus I2 R2. So now I keep traveling as I pass through the EMF1, I will have a potential rise. Okay, I'll have a potential rise when I pass through the EMF1 because I'm moving from lower potential, the negative terminal, towards a higher potential, which is the positive terminal. So plus EMF1. Okay, and now it has come to an end at point A. So now I have a complete blue color loop. So this equation is now equals to 0. So as usual, I'm going to plug in the value. Okay, so negative 1I1 minus 12 minus 2I1 minus 2I2 plus 6 equals to 0. Rearrange the equations, you should obtain 3I1 plus 2I2 equals to 6. Okay, equals to 6 if I'm not mistaken. Yes. All right. So this is my equations number 3. Okay, this is my equations number 3. So what am I going to do now? I'm going to put all 3 of them together to make it more tidy. So equations 1, I have I1 minus I2 plus I3 equals to 0. Equations number 2, I have 0 I1 plus 2I2 plus 4I3 equals to 6. Equations number 3, now I have 3I1 plus 2I2 plus 0I3 equals to 6. Okay, so these are the equations that I have. So now what I want you to do, I want you to key in this value in your calculator and see whether you can get this set of answer or not. I1 is equals to negative 1.85 ampere. I2 is equals to negative 0.23 ampere. I3 is equals to 1.62 ampere. Okay, see whether you can get this set of answer or not. All right, so now I give you 3 minutes to complete questions 1 before we move to questions 2. Okay, this questions 1, you solve it first. If you cannot get the answer, you let me know. All right, 3 minutes for you to try it, to solve it, to complete it.
Madam,
Yes?
equation 3 tu negatif 6.
Oh, equation 3 negatif 6. Thank you. Okay. Ya. Negatif 6 enggak? Macam mana kamu dapat negatif 6? I tengok apa yang saya salah buat di sini. Oh ya, saya salah pindah. Thank you very much. Negative 6. Okay, so semua boleh dapat I1, I2, I3. Oops. Okay, so now let's look at questions B. Okay, questions 2. So what does it imply if your calculated current is negative? Okay, I remember I told you before, that is because the actual directions of the current flow in the circuit is opposite to your chosen direction, okay, to the directions of I that you sketch in the diagram when you apply Kichoff rules. Okay, so how am I going to write it here? I don't have enough space now. Okay, wait, I'm going to write it here. Okay, so you just copy it lah. Okay, you just copy it. So questions number 2. Okay, it implies that the directions of the actual current flow in the circuit is opposite. Okay, it's opposite to the chosen direction. Okay, to the chosen direction when applying Kichoff. Remember, it's double H. Okay, Kichoff rules. Okay, Kichoff rules. So that is the answer. Okay, that is the answer. Now, what does it mean? Okay, so if you look at the diagram just now, okay, if you look at the original diagram, now it tells you your I2 is entering junctions A, I3 and I1 is leaving. Okay, that is what happens in our original diagram. Okay, that's what happens in our original diagram. So which means if you look at the questions, the answer in the questions 1, I1 is a negative value, I2 is also a negative value, meaning that the actual directions of the current flow in the circuit, but not based on this diagram, the direction it should be like this. Okay, it's opposite to the diagram given. So diagram tells us that I1 is leaving, but the actual direction should be entering the junction. I2 is entering, but the actual direction should be leaving. Okay, that is the meanings of the negative sign. Okay, a negative sign in the answer. So that's why I told you guys before, when you get a negative value, it doesn't mean that you are wrong. Okay, it simply means that the directions that you give is opposite to the directions given. Okay, the directions given right here, it should be like this. Okay, dia sepatutnya arah begini. This is the actual direction. Okay, this is the actual direction. Tapi soalan bagi kita yang terbalik. So it doesn't matter, okay? It doesn't matter. Why? Because based on the values given, we already know that the diagram that we sketch is not following the actual direction. That is our chosen directions, our given direction. Okay, so that is how you explain it. actual current flow, actual directions opposite to the chosen direction. Okay, actual directions opposite to the chosen direction. That is the answer. Okay, so I think that is quite simple. Now let us go back to questions number 3. Questions number 3 is a very interesting question again. Why? Because you need to identify the path that you want to use. So this one we are done, right? I'm going to put a diagram right here. Okay. So now let's see, how are we going to solve questions number 3? You want to determine the potential difference between x and y. Okay, between x and y. So it doesn't matter whether you start from x or start from y. All right. So what are we going to do right now? Okay, we are going to draw the path. Okay, your x is located at here, y is located at this point. Okay, at this position. So what am I going to do? I want to identify how many paths can be taken. Okay, how many paths can be taken to travel from x to y, let's say. So according to this diagram, I have 2 choices. The first one is on the left-hand side. Okay, if I start moving from x, I will pass through, I will move through my EMF. I'm going to label it again, yeah, wait. R1, R2, R3, R4. EMF1, EMF2. So if I start moving from x, I have 2 choices. The first one is on this left-hand side. Okay, that is how I can travel from x to y. And the second one is on the right-hand side. Okay, I have 2 paths that I can choose, I can use to travel. So this question number 3 actually is not related to questions 1 anymore. Okay, you're going to need a new diagram in order to identify the directions of your travel, of your journey. Okay, kamu sendiri pilih arah mana yang kamu nak guna, path mana yang kamu nak guna untuk bergerak daripada X ke Y. So you can choose to move from Y to X as well. It doesn't matter. Why? Because the question just asks for the potential difference between point X and Y. If the question asks you to determine the potential difference from X to Y, then you must use Vy minus Vx. Okay, the difference between the terms. Between, it doesn't matter. You can use Vx minus Vy or Vy minus Vx. If the question say from X to Y, then it must be Vy minus Vx. If a question say from Y to X, then it must be Vx minus Vy. All right, you will get a negative sign, an opposite sign. Depends on the statement given. But when it comes to between, then it doesn't matter. Okay, when it comes to between, then it doesn't matter. All right, now let us see. How are we going to form an equation? So we are going to start from point X. Okay, we're going to start our journey from point X. So start from Vx. Okay, start from Vx. So now I'm leaving Vx, okay, and moving towards EMF1. As I pass through EMF1, what happened is I'm traveling from negative toward positive, from a lower potential to a higher potential. So this is a positive value. Positive EMF1 plus positive EMF1. As I keep traveling, okay, and now I'm come to R3. Okay, I've come to R3. All right. So when I pass through R3, it experienced a potential drop. Okay, and since it's experienced potential drop, and the directions of the loop and the current, they are pointing towards same direction, meaning that I will have a negative IR at this point. Okay, so minus I1 R3. Okay, minus I1 R3. How do I know it's minus? Because both the traveling directions and the current, they are pointing towards the same direction. And as passes through the EMF2, what is happening is, okay, now I'm traveling from higher potential towards lower potential. So this is a negative EMF2. Okay, and after I pass through this EMF2, I've now come to the final destination, which is a Y. okay, which is the y. So it is equals to Vy, all right? If you rearrange the equation, Vx minus Vy is then equals to, Vx minus Vy is then equals to negative EMF1 plus I1 R3 plus EMF2, okay, plus EMF2. So if you plug in the value correctly, you should obtain 4.15 volt. This is the answer that you should get if you got it right. Okay, if you got it right. Now let's see, what if I travel towards the other direction? So again, I'm going to start from X. Okay, if I start to travel from X, I will start from Vx. Okay, I start my journey from Vx. So if travel towards the right-hand side, as it passes through R2, okay, what happens right here is that if you look at the original diagram, I2 is going to the left-hand side. Okay, I2 is going to the left-hand side. What happens when I pass through I2 is that now my current flow and my traveling direction, they are opposite to each other. Okay, so if we say they are in the same direction, it experiences potential drop. Okay, now since they are opposite to each other, what happened is now I will have a positive value. Why? Well, because by knowledge, by common sense, when it experiences potential drop, it should have a negative I2R2. But now because the current is against the traveling direction, so the whole thing becomes negative I2R2. This negative is because of opposite direction. Therefore, the final values, the final things that we're going to use in our calculation would be positive I2R2. Okay, positive I2R2. So whenever you pass through, okay, whenever you pass through, you walk through a resistor, it should experience a potential drop. And if a current and your traveling direction, they are pointing toward the same direction, then we can remain as a negative value. But if they are against each other, then the actual case, the scenario will become negative. Okay, negative a negative value. So you're going to use a positive value in your calculation, okay, because of the opposite direction. So Vx plus I2R2, okay, plus I2R2, because now my traveling direction and the current, they are against, okay, they are moving to opposite to each other. So I have a plus I2R2, and what happens? I keep traveling. Again, when I pass through R4, what happened? Once again, my I1 is going to the right-hand side, but my path, my chosen direction is going to the left. Okay, my traveling direction is going to the left. Left and right opposite to each other against the directions, okay, against each other. So I have positive, okay, positive I1R4 now. Okay, positive I1R4. And then, okay, when it comes to a Y, okay, I've now reached the final destination. So it is then equals to Vy. Okay, it is then equals to Vy. So am I right? So the traveling direction against, yes, against, yes. Okay, so if I rearrange the equations, okay, if I rearrange the equations, Vx minus Vy, eventually I will get 4.15 V as well. Okay, if I got it right. If you plug in everything correctly, okay, this is I2 R2 plus, oh, not plus, sorry, it should be minus. Negative I2 R2 minus I1 R4 is equals to 4.15 volt. Okay, so if you got everything right, then that is the final answer. Now here you might ask me, negative I2 R2 minus I1 R4, how can you get a positive value right here? That is because you have negative I1 and negative I2 just now. Okay, so negative, you should obtain a positive final answer. All right. So again, I give you 2 minutes to write it down. Okay, write down both methods. Make sure you understand how to apply both of them, how to use both of them. Okay, the blue color path and also the green color path. So 2 minutes from now. Okay, so I hope you can understand questions 1, 2, 3. Basically, these questions covers everything that we have learned in chapter 3, subtopic 3.6. Okay. Now the last question is quite interesting as well. Why? Because it's asking for total power dissipated, total power loss. So when it comes to power loss, remember that I told you power loss it only happens in resistor, okay, and also in an internal resistance. So if the question is asking for total power dissipated, total power loss in a circuit, you look at the diagram and see how many resistors you have. You have R1, you have R2, you have R3, you have R4, right? So you just have to add all of the power together. So total power loss, okay, total P loss, okay, P loss is equals to, well, now to make it easy, I'm going to use I square R, okay, I square R. P loss equals to I square R. So total power loss, total P loss, oops, okay, total P loss is equals to, now let us start from R1. R1, we have current I3, okay? So I3 square R1 plus, okay, now we have R2, we have I2. So plus I2 square R2 plus again. How do I know that I need to plus again? Because I still have R3 and R4. I have 4R means that I have to add them 4 times. I have to add up the 4 powers together. So R3, I have a current I1 flowing through it. Okay, I1 flowing through it. So I1 square R3. R4 also I have an I1 that is flowing through it. So plus I1 square R4. Okay, plus I1 square R4. And then you should obtain 20.9 watt. All right, so total P loss in this case, because you have 4 resistors, therefore you have to add up 4 of them, okay? You have to add them up. The power from all 4 resistors. So you need to have 4 terms, okay? Kita tengok betul tak? First power, second power, third power, fourth power. So kalau ada 4 power dengan 4 resistor, then that is right. Okay, that is correct. So anda kira and you should obtain 20.9 watt, right? So 3 minutes for you to write it down before we proceed to the next question. Okay, next we are going to try a one loop question. All right. So now let's go Kichoff law question, but it is a one loop question. Okay, in 2012, 2013 past year question. So like I told you before, every year you're going to have a Kichoff law question. That's why I wanted to put more effort on a Kichoff law. Okay, sebab dia setiap tahun memang akan ada. Kalau kamu tak reti buat, memang rugi lah. Tak tahu dia akan keluar dalam exam, tapi kamu tak fokus kan? So now you look at the past year questions, 2012, 2013. Okay, 2012, 2013, questions 2B. One loop question. Okay, soalan satu loop. So let's see how are we going to solve it. Yeah. So you guys try first. Okay, so I edit skip. Oops. All right. Okay, now let's look at the diagram. This diagram, okay, if you notice, okay, you are given a value, okay, a values with a comma across the battery. When you have a comma with a values with a unit ohm, then it indicates this value, it belongs to internal resistance. Okay, it belongs to internal resistance. So you have two internal resistance in this question. So let us label the diagram as usual. EMF 1, internal resistance R1, external resistance capital letter R1. Okay, capital letter R2, EMF 2, internal resistance R2, capital letter R3, external resistance. And this question, it gave you the directions of the loops already, okay? It gave you the directions of the loops already. So you just follow the directions of the loops. So what are we going to do right here? Okay, what are we going to do right here? It's very simple. Okay, it's very simple. We just have to follow the path given. Okay, we just have to follow the path given. And of course, before that, you need to identify the directions of current first because you are not given the directions of current. So if you remember the things that I told you in the previous class, you compare the values of EMF between two batteries. Okay, you compare the values. If they are pointing, if they have a same terminal facing each other. But in this question, it's very simple. Why? Because now the positive is being connected to the negative of the other battery. Okay, so they are facing towards same direction. The terminal, they are not facing toward each other. Okay, but they are facing towards same direction. So in this case, you just follow the directions of the current. Okay, the directions of the battery. So the I should be flowing in the anti-clockwise direction according to the diagram given. Okay, this is my I. So I have I flowing in the anti-clockwise direction, and the loops given is also anti-clockwise. So what are we going to do now? Okay, well, when you have a one loop questions, you don't have to apply first law. Remember, that is what I told you before. Why? Because there's no junctions in our question. Therefore, you don't have to apply Kichoff first law. Okay, straight away, we can start from Kichoff second law. Delta V equals to 0. Okay, delta V equals 0. And then, well, let us start from one point. Okay, choose a point and begins from there. Let us choose here. This would be my starting point. Okay, my starting point. So the loops given is in the anti-clockwise direction. So I'm going to move in the anti-clockwise. I'm going to travel in the anti-clockwise direction. So start from this starting point, I travel in the anti-clockwise direction. As I pass through R1, because the journey, okay, my traveling direction and the current, they are both pointing towards same direction. So negative IR1, okay, negative IR1. As I keeps moving, and when it comes to this first battery, now this first battery, I'm moving from negative terminal towards positive terminal, lower potential towards higher potential. So plus EMF 1. But don't forget there's an internal resistance right here. When there's an internal resistance, then you just have to treat it like all the other resistor in your calculation. Okay, bila kamu buat pengiraan, kamu anggap dia sama macam resistance lain. apabila kita buat equations untuk Kichoff law. So this current is flowing to the left-hand side, and my traveling direction is also to the left. Therefore, it is a negative IR1. Okay, negative IR1. So now I'm going to keep traveling and pass through R2. Okay, now I've come to R2. So when I pass through R2, okay, when I travel through R2, the direction, the traveling direction, once again, is same as the directions of current. Therefore, I'm going to put another minus here, minus IR2. Okay, minus IR2. And I keep traveling, and I've now come to my second battery. Okay, second battery, I'm traveling from lower potential towards higher potential. So it experienced a potential rise. So I'm going to plus EMF2. But don't forget about the internal resistance. Internal resistance causes the potential drop in my circuit. Okay, and since the traveling directions and the current direction, they are both pointing towards the same direction. So I'm going to use a negative sign right here again. Negative IR2. Okay, negative IR2. So it keeps moving, and now I've come to a R3. When I pass through R3, once again, traveling directions and the green color current, they are both pointing towards same direction. So once again, it experienced a potential drop minus IR3. All right. After that, I keep moving, and pop, I'm back to my initial position, my starting point, which indicates that that is the end of my journey. So it is equals to 0. Okay, it is equals to 0. So next task, you just plug in the value, and eventually you should obtain your I equals to 0.5 ampere. Okay, your I should be equals to 0.5 ampere. So that is your questions 1. Very simple, okay? Very simple compared to 2 loops question. You just need 1 equation. Okay, you start from Kichoff second law, you form 1 equations, and then you will get the answers that you want. Questions number 2. Okay, questions number 2. Question asks you to calculate. Okay, it asks you to calculate what? It asks you to calculate the potential between AC. Okay, between AC. So let's look at the diagram at the bottom. Okay, a brand new diagram yang tak conteng-conteng lagi. So, well, in diagram is a bit confusing. Why? Because they give A, B, C, D. Seems like they want you to calculate a lot of things, right? But actually, itu tipu orang, all right? If you look at the question, it just want AC. So you highlight your AC first. AC is here. Okay, AC is here. So how to travel from A to C or from C to A? You have 2 choices. First is through this short path, through the battery. Straight away, you can get the answer. That is the easiest one. Okay, and AC also indicates the potential, terminal potential difference. Okay, terminal voltage of this EMF1. If you don't want to use this short path, this shortcut, you can also determine the value through this external path. Okay, through this external path. So from A to C, kamu ada 2 cara. Path biru atau path hijau. So obviously in this question, it will be easier if you use the blue color path, the shorter path. All right. So let's see if I start from point A. Okay, if I start from A, let's say now I'm going to start from A. So VA, if from VA, I want to travel to VC. Okay, now you ignore the path given. Okay, you just look at this blue color path that I draw. So if I want to travel from A to C, I start from A. When I pass through this battery, what happened? I'm moving from higher potential towards lower potential. So it will become negative EMF1, and then I've come to the end of the journey, VC. Rearrange the equations. I have VA minus VC equals to EMF1, which is equals to, oh wait, I forgot about the internal resistance. All right, so after that, I have another plus IR1, okay, because it against the directions of current. This is the directions of current, but then my traveling direction is to the left. So I have a plus IR1 equals to VC. VA minus VC is then equals to EMF1 minus IR1, okay, which is our potential, the terminal potential difference, terminal voltage of a battery 1, because EMF 1 minus IR 1. Okay, we should then give you a 6 minus 1 times 0.5. So the answer VA minus VC should give you 5.5 volt. Okay, 5.5 volt. If you use a short path, okay, if you think this is too short, too easy for you, not challenging, then of course you can use the green color path. So start from AC again, start from VA again. Now you're going to travel through this green color path. Okay, you're going to travel through this green color path. So basically, the green color path is quite similar to your first questions, your questions 1. All right. So if you form everything correctly, if you got everything right, okay, you should obtain, okay, this is my R1, this is my R2, this is my R3, EMF2, R2. If you got everything right, you should have a minus IR2 plus EMF2 minus IR2 minus IR3 equals to 0. Not 0, sorry, VC. Okay, equals to VC, your final value. Okay, your final value. You're starting from an initial position. It passes through 8 ohm resistor. It passes through the EMF2. It passes through the internal resistance. Passes through R3 and goes back to R1. Aha, I'm missing out at R1 right here. Okay, I have one more, negative IR1 equals to VC. Okay, you try and see whether you can get these equations or not. And if you rearrange the equation, eventually you should obtain 5.5 volt as well. Okay, you should obtain 5.5 volt as well, if you choose to use the green color path. So nothing's wrong. Okay, in exam, it is up to you whether you want to use the blue color path or the green color path. Both are accepted. Okay, both are accepted. Just depends on how you draw it, how you calculate it. You need to show the diagram in your answer, so the examiner know what are you doing. Okay, diagram sangat penting apabila kita menjawab soalan circuit, sebab dia melibatkan arah. Kamu guna arah clockwise ke, arah anti-clockwise ke, semua Anda kena tunjuk dalam diagram. Supaya orang yang tanda Anda punya skrip, Anda punya jawapan, dia tahu apa yang Anda tengah buat. Okay, kadang-kadang Anda tak tunjuk, Anda semua bagi nilai. Orang yang makin itu dia tengok-tengok, tiba-tiba dia tak faham. Habis. Walaupun konsep Anda betul, tapi orang yang Anda tak faham apa yang Anda buat, Anda tak akan dapat markah juga. So Anda kena state semua dengan jelas dalam jawapan Anda, supaya orang yang tanda paper Anda, dia tahu apa yang berlaku. Alright? So, okay.